Solve for x and y in the matrix equation. And here we have this matrix equation right here. Now, we have this matrix, and this matrix is of order 2 by 2. And we know it is 2, and we know that its order is 2 by 2 because it has 2 rows, this row, and 2 columns, this column and this column. So 2 rows and 2 columns. And if we look at this one, right, this matrix, it's also of this matrix right here has an order of 2 by 1, not 2 by 2, but 2 by 1, because this matrix has 1 row and the next row, so it has 2 rows, but 1 column, all right? So notice that the first matrix is of order 2 by 2, the second matrix is of order 2 by 1. But these two numbers are the same, right? So these two numbers are the same, which means that we can multiply these two matrices in this order successfully. But we also can derive from this is that the resultant matrix, or the order of the resultant matrix, is going to be 2 by 1, 2 by 1. And what does a 2 by 1 matrix look like? Or how does a 2 by 1 matrix look like, right? How does a 2 by 1 matrix look? Well, a 2 by 1 matrix is going to have 2 rows. So this is row 1. So 2 rows, row 1 and then row 2. But it's also going to have 1 column. So column 1 and then column 1. All right. So what do we have? Well, we're going to have a matrix that has 2 entries. This entry, which is in row 1, column 1, and this entry, which is in row 2, column 1. And so let's go ahead and multiply these two matrices. Now we're going to use this as our formula. So row 1, column 1. So we're going to take row 1 multiplied by column 1. And so we have 2 times x, which is 2 times x here. Then we have -1 times 3, which is -1 times 3. So that's row 1, column 1. Next, we have to go to row 2, column 2. So we have to go to row 2, column 1. So row 2, column 1. Row 2, column 1. So we have 3 times x. That's 3 times x. We have -4 times 3, -4 times 3. And this is equal to 17y. Next, we have 2 times x. And 2 times x is 2x. Next, we have 1 times 3, and 1 times 3 is 3. Next, we have 3 times x, and 3 times x is 3x. Next, we have -4 times 3, and -4 times 3 is -12. So we have 2x plus 3, and we have 3x minus 12. That's equal to 17y. Now, notice that this matrix is equal to this matrix. That's based off of how the matrix equation is set up. So if this matrix is equal to this matrix, what does that mean? Well, if two matrices are equal, then that means that corresponding entries are equal. So that means that 2x plus 3 must be equal to 17. And so 2x plus 3 is equal to 17. And then 3x minus 12 is equal to y, all right? That's if these two matrices are equal. If they are equal, then corresponding entries must be equal, all right? And so what do we have next, right? We have to take this 3 and send it over the equal sign. It was a +3, but when we send it over the equal sign, it becomes a -3. And so we have 2x is equal to 17 minus 3. What is 17 minus 3? Well, 17 minus 3 is 14. And so we have 2x is equal to 14. We divide both sides of this equation by 2. So there's 2, we cancel this one with that. And so we have that x is equal to 14 divided by 2. And 14 divided by 2 is definitely 7. So x is equal to 7. Now we know what x is. What is y? Well, we know that 3x minus 12 is equal to y because these two corresponding entries must be equal in order for the two matrices themselves to be equal. And so 3x minus 12 is equal to 3x minus 12 is equal to y. Again, 3x minus 12 is equal to y. But what is y? I'm sorry, 3x minus 12 is equal to y. But what is x? X is 7, we know that. And so we substitute x is equal to 7 into this equation. And so instead of putting x, we put 7. And so we have 3 times 7 minus 12 is equal to y. We multiply 3 times 7, and 3 times 7 is 21. So we have 21 minus 12 is equal to y. And 21 minus 12 is 9. So we have a 9 is equal to y, or y is equal to 9. And so that means that x and y in this matrix equation, x is equal to 7 and y is equal to 9. And that's the answer to this equation.